Okay, now here's an update, on what's going on. Now here is the design, for the product, the LED candle that I showed you CAD files of. These are the 3D prints. I've already kind of glued some of this stuff together. Not completely, though. Actually, I haven't really glued anything together yet on this. But yeah, I made my little rocking mechanism, which this is the first prototype I printed out. And actually some of the flaws you see in this are actually due to my CAD software, which I actually figured out had some, Rhino would actually, on the settings I had, it would actually develop some, imperfections in the mesh that it would generate. So the STL files kind of came out bogus, with little imperfections in it, like you can see this little dent right there. That's actually in the file. So, and I could actually see that on some other parts too. But anyway, that's, something I kind of got resolved since I printed these things, including some of this roughness you see. See those striated patterns, that go from coarse to smooth along there. That's actually part of the file too. So, the 3D printer actually does a better job than this. But yeah, I printed, like I said, this base to it that you kind of saw in the designs, and like I said, the swivel diffuser on the top, which works pretty cool, but it doesn't have full travel. So as a result, I decided to make some design modifications, and I don't know what I did with that thing. No, here it is. But yeah, like I said, I also did my little magnet thing, which you can kind of see there, and it kind of works. I'll slide it in there, and you can kind of, well, I'll take it out, and then I'll just assemble this thing. Let's see, where did the other piece of it go? That's the bottom. And when I'm doing this in a 3D printer, it's just easier right now, since again I don't have that thing fine-tuned. It's just easier to print this. See, normally if I had this thing produced, it would be injection molded as a single part like this, but in a 3D printer, I had to print this like that upside down and that upside down, so it builds up, so I don't have to use support materials under some of these ridges and stuff, because otherwise, these overhangs would be a bit of a problem. And I had some overhangs in this too, but I actually had to go and kind of chamfer the edges, you can see right there, because I actually printed this standing up. So it had some overhangs, but there's actually a chamfer on that, so it's not it's not just a flat overhang. It's shaped like that a little bit. But at any rate, those are some 3D, design tricks if you want to get away from having to deal with support materials. Right now my printer, I just don't have it tuned up, so the support material is almost impossible to remove. But anyway, this would be a single part, and that's what contains, the circuit board would go right here, and little slide switches. Let me put this on flower mode so you can get a close up, and less blurry close up of it. Darn it. But yeah, there's like two little switch wells here, so the switch, switches go in this little, recess, and, another one goes over here, and the circuit board kind of goes on top of it, and, like I said, our little magnet thing, slides in there, kind of like I was talking about a little bit on the design, I think, if I remember correctly. It's been a couple of days since I've made the video. And this is the cover, that I printed with the little, like I said, rocker mechanism in it, so the counterweight on it. Like I said, that slides in this little groove there, just like that. And normally this will, when it's glued together, it'll set, but I hadn't actually glued anything yet, except the base. I did, glue the base lid, but the thing is, it's not fully traveling like I wanted it to. So, but like I said, if you do it like that and then set it up right, you got that. Now if you stick this sucker in here, where'd it go? stick our magnet thing in there. It just kind of draws itself in. Kind of like that thing on Superman or Man of Steel. Anyway, the fact of the matter is, with that in there, it has a slight resistance, see, so, but it still doesn't really hold it, so it's really just, it's kind of an experiment I wanted to try, but I need really a stronger magnet or a bigger, larger steel mass in there than this, but I just can't accommodate a bigger one because of the clearances just aren't there. Anyway, that kind of stabilizes itself faster than without the magnet, without the magnet, it kind of just bobs back a little bit, back and forth a little bit. At least this way it, stabilizes itself faster, with less, it dampens the oscillation. Well, it dampens the oscillation when it's pressed in, but I don't know. I mean, it's kind of useless. It might be good, somebody that's in an earthquake zone, it'll wiggle around a little less. But I mean, otherwise, it was just an experiment. That's the great thing about 3D printers. You could try experiments like this. But anyway, I went ahead and dropped that model and went ahead and did this model, which is actually slightly longer. So it's a little larger. So, but because of that, I've got a bigger, I got full travel on it now, so it fully opens, because I want it so you can grab your finger, if you wanted to, like, use it as a flashlight pointing up, so I got it so you can grab it with your finger, and, so, you can, use it as a flashlight that way, but you can also grab it with your thumb and hold it open if you want, and then release it. But anyway, it's kind of a novelty, and I think this whole thing could be shrunk, but again, the problem is that counter mass, that counterweight in there, requires a pretty substantial mass to offset this. Now, when this is made in production, this will likely be made out of this 2447 acrylic. Now, this is a lot higher density than what I've got on this 3D printed diffuser right now, because that's actually very thin, and therefore it's got a very low amount of a very small amount of mass there, so it's easier to counterweight. I'd need a bigger counterweight, to actually offset something, this, if it were made out of a denser material, and the whole thing would probably be made out of acrylic, the mast and support everything. But like I said, that the other model, had travel restrictions. You can see how tight it is, because the counterweight, is one thing, and I'm just kind of throwing things at it just to see. But like I said, if I had something higher density, like, platinum, would be great, but, that's kind of expensive. Lead is, about 1.5 times the density of steel, but, it's still difficult to offset this torque arm, and you can't make this too long because it runs into the cover. So I have a feeling this thing could be shrunk a bit from its current size, but it's just hard to say how far you can go with it, and still, with my current constraints, I've got to, when I do something like this, I got to do it safe. Yeah, but a lot of these imperfections you see, again, are actually imperfections in my file still, because I hadn't figured that out yet at the time I printed these. But, a lot of these little dimples and stuff are actually imperfections in the mesh coming out of my CAD program. They have nothing to do with the 3D printer. But again, I changed the shape of it a little bit, to smooth this out a little and everything, and it's much better design. And this, has the bottom lid on it, which actually unscrews out of there. And this is nice and tight. This is a refined version of this one, which, here's the lid, which is this is the only thing I do have glued together are these lids right now, because that's a two-part. This is, printed from this way up, and then this side printed from that way up. So, and then I glued them together, so, you can see how they, will go into the indentations there and just kind of twist around. But this is fairly loose when you do it, and but this one I tightened up a lot, because I'm still getting the feel for the tolerancing on this printer too. So, so this is all, part of a learning experience. I'm not only getting products developed here, but I'm also trying to learn how to most effectively use this printer and what its, what its tolerances are, and I tend to be pretty conservative. But like I said, you know, I really like that about 3D printers, is that they force you to be conservative, which is good, because it could get you to market with less tooling expense. And I've actually got another um, oh, what would you call it, a monologue on that I did on tape, with, you know, not on video but on tape, and I'll probably make that part of this series too, about the advantages of a 3D printer and why it can save you a lot of money from an engineering perspective, you know, and a parts development perspective, because it does force you to be loose on the tolerances. And that means that if you have injection molded parts based on that, they're likely to at least fit. They may be too loose, but when you 3D print something, you got to give it pretty generous tolerances, because it's not a high precision print job. You can't count on it for being as high precision as you're going to get out of a, you know, injection molded part, for example. And on top of that, the plastic is going to have, an injection molded part is going to differ considerably from the plastics you're going to use with a 3D printer. So the mechanical properties will be a lot different. So you got to keep that in mind. So it's best not to be too adventurous. And as long as you keep to that moniker and design around that for your first product that you're trying to put out in the market, you'll at least, when you finally commit to the tooling, which tooling on injection molded parts can run a lot. Like, this wouldn't surprise me if, you know, all these different parts, you know, ran 30 to 50 grand, you know, to have tooled up, you know, for these different parts. That wouldn't surprise me. And so, you know, it's good if you're going to throw money into it like that, to make sure the parts are going to run, that at least that first tooling that you invest that kind of money in, you can actually go to market with. Even though it might be loose, it might cost you more assembly time trying to overcome some of the imprecision in it, but it'll get you on the market with a first generation run. You know, to be something that's marketable, you know, to get you started. And that's the whole point, you know, is that you've got to be careful. Unless you just got a boatload of money to work with, you know, you got to be careful. But here, you know, we're working on a shoestring budget. We don't have tons of frickin' money to throw into stuff like this, you know, into prototyping here. I mean, you know, we don't. So the fact of the matter is, you know, I know a few tricks about how to keep things cheap. And that's some of what you're going to learn, you know, in this documentary series. You know, is some of these little tips and tricks that I've learned over the years. And, you know, particularly on how to, you know, get a product out of the market on a tight budget. So that's what we're going to explore here, you know, succeed or fail. But at least you'll learn something, you know, about the do's and don'ts based on what the final outcome of this whole thing is. Anyway, this is the next product that I went ahead and started. It's the TacLite product. I was going to document the actual design of that product for you. You know, I thought that would be educational, but unfortunately I don't have a good enough microphone, because I had to hold that damn thing about 3 inches from my mouth. I can't do it with the camera, because I have to set it back where I am to actually get the whole, you know, screen in the shot, so it's not practical to do it with this camera. So, you know, I'm just kind of stuck on that until I get a better microphone, and I'm about to order one from Amazon. But at any rate, I went ahead and started on the TacLite project, you know, which this is one of the prints. And again, these are multiple parts glued together. I think I do have one that I have not glued together yet. It was a test print, you know, so you can see, you know, here's what I call the tack disc. And I had to buy these tacks from actual Taiwan. They're very long tacks. They seem to be the only people in the world that make them. But at any rate, again, this little disc kind of slips on there like that. Let me flower them. I need a better camera than this. Anyway, and then this is actually a two-part deal too. And this normally, you know, actually glues to the back of this, you know, to make a complete piece. And then the lid, you know, that's for the little kind of lanyard or strain relief for the wire, you know, to go through to the TacLite. You know, it kind of slips over and the circuit board will be contained in there. So that's kind of how it works, and you kind of see that. And this is one of the refined models. I've actually done about 4 of these. You know, this is testing the wire going through this older model. But anyway, it looks like it might work pretty cool. So again, I'll keep you updated on that. I'm thinking about moving on to another project because I'm trying to, you know, with my little my little Roland over here, you know, I've got this circuit board, you know, material left, and I had to tape this down with double-sided tape and everything. So what I'm trying to do is I'm trying to save up until I get enough circuit boards designed to actually do them all at once, because you have to go through several steps to make a circuit board for that thing, you know, including putting drill bits in there, and then putting router bits, and then, you know, routing the file, and it's a pain in the ass with the software they have. So that's why I try to actually do it in steps. So I'm trying to actually fill that whole circuit board, that whole blank PCB, what's left of it there, before I actually print the circuit boards for it. So that's why right now I'm mostly focusing on the cases, you know, and trying to get some of this stuff done. Well, I guess I should have, in case that was too blurry, I had it in flower mode. But yeah, that's, you know, like I said, I just want to fill, you know, this material up, you know, use all of it. The next circuit board run, this first one is just the one I did for that little 9-volt candle, and I just did that to test the whole process. But I want to fill that whole card up before I print, so I can just dispose of it. Because I actually wanted to take some of this acrylic here and try to make, you know, a version of one of these, you know, for this LED candle out of acrylic, and use that acrylic cement for it, because it works really, really well. But I want to get that out of the way because I'm going to have to load that acrylic up on that printer. But right now the circuit board's in my way, and I don't want to have to go and untape it. So anyway, the point is, though, is that's where the state of it is, and, you know, again, I'll update you in the future.